previous videos, we discussed the structure of PCBs and the basic parts of Eagle. Today, we will focus on using the schematic window and design principles to help you make your schematic and help others identify specific portions of your designs. In case you need a refresher, the schematic represents the components and the connections between them. The schematic window allows you to connect these components together with nets. These nets will later dictate which pins and pads to connect together in the board view to make the final circuit board. Before making your own schematic, let's take a look at another one of RJ's projects to see what the finished schematic should look like. First, taking a look at the component connections or nets, we can see that most of them are labeled, and the power lines have their voltage level and maximum allowed current listed next to them. Next, note the presence of power and ground symbols to denote these special nets, rather than have all these power rails connected. This is yet another way of ensuring that the circuit is organized and readable. Now we are ready to start making our own schematic. Here's a scenario. We want to make a shield for an Arduino Uno that takes an external 9-volt power and uses a digital I/O pin to control a green LED with a simple 3-pin NPN transistor. The image on the screen shows the circuit we want to make. Let us start by setting up the grid. The grid is what all the parts and connections snap to. Right now the grid is invisible and in the wrong units. Let's fix this. I like using the ribbon on the side and top for all my actions, but you also can type in the command line the keywords for every action to accomplish the same tasks. For example, instead of using the grid button here, you can simply type grid into the command bar and Eagle will open the same window for you. To change the setting, open up the grid menu by clicking on the grid button. We want the display style to be on, the style to be lines. For the size, we're using mils per unit. These are a thousandth of an inch. And size 100 with 10 for alternate. The alternate size is used when you press the Alt key and can help line up some parts that have been made with different grids. So now we're at the point where we need to get started to make this schematic, and for that we need parts. However, since RoboJackets has our own curated library of parts, we want to use those instead. A previous video should have mentioned that you should have copied the library files from the RoboJackets GitHub repo into the libraries folder Eagle creates in your computer's home directory. While there is a better solution, we're going to leave that to after this video. We're going to open up the library manager. So go to library in the top bar and click on the library manager item highlighted here. We want to go and use the new RJ libraries from the Available tab. And delete the bundled libraries in the In Use tab. Now we should only see RJ libraries in this section. Now we're going to add all the parts into our schematic using the Add Part button highlighted here on the ribbon, or you can run the command Add in the command bar. We can either use the search bar to find the parts we are looking for, or use this window shown here. Some parts have multiple footprints, so it's important to select the footprint that matches the physical device you are using. Once you find the correct part, double-click it or click the OK button to select it. Then click anywhere to put that part down. For now, our goal is to find all the parts we need and place them into our schematic. However, in doing this next search, I can't find the part that I'm looking for. The wildcard character, the asterisk, is a symbol that represents arbitrary text, meaning that if I put one before and after my search term, I will find all the parts that have that search term somewhere in it. In addition, we need the power and ground symbols that I mentioned previously, so we can search and add those as well. Repeating the searching process, we can get all the parts we need into the schematic. Use this list on screen to finish up while we speed this up in the background. To continue, we can move the parts around to create space around them and move the symbols closer to them. To do that, use the Move button highlighted here on the ribbon, or you can run the command Move in the command bar. Then click and move the parts or symbols individually to their respective new locations. Now, we want to rotate parts so they line up in certain orientations to make the schematic easier to connect. We can rotate the resistor such that it faces vertical. To do that, use the Rotate button highlighted here on the ribbon, or you can run the command Rotate in the command bar. Then, left-click on the resistor so it rotates 90 degrees counterclockwise so it faces vertically. Now, a schematic is useless if it doesn't give information on the parts we're actually supposed to use. We need those values to actually build a circuit. So now let's add a value to this resistor. To do that, use the Value button highlighted here on the ribbon, or you can run the command value in the command bar. Then left click on the resistor and type 220 into the box that pops up. Now we can speed this up to get to the next stage, which is actually adding the nets and labeling them. Now let's use nets to actually connect everything. Looking back at the image of the connections, we can figure out which pins to connect on the parts we have. Let's start by connecting the LED to the resistor. To do that, use the net button, highlighted here on the ribbon, or you can run the command net in the command bar. Then, click on one of the pins of the LED, seeing a small circle pop up, and then drag to the next pin on the resistor, and click when you see another small circle. This means that you have joined the two parts. Let's also do something to set up for later and create a net that we will label. This will allow us to connect to it later from a different part of the schematic. Do a line horizontally from D9, and then we can even click in the middle to make a right angle. But, whoops, we've made ours too long by accident. Well, we could just undo this. Let's learn a tool that we can use to delete sections of nets as well as parts. The delete tool. To use, click the delete button, highlighted here on the ribbon, or you can run the command delete in the command bar. Then left click on what you want to delete, in this case, the super long net. Now, we need to label that net so we can connect to it later. However, first we're going to have to name the net using the name tool. To use, click the name button, highlighted here on the ribbon, or you can run the command name in the command bar. Then click on the net you want to rename and give it a descriptive name. Now we're going to use the label tool to display that name. To use, click the label button, highlighted here on the ribbon, or you can run the command label in the command bar. But before you click on the net, however, you want to change some settings. So first you want to make sure it's a trapezoidal label and a size of 50. Then click on the net and position the label at the end, using a right click to rotate it until it lines up. Use this image on screen to finish up while we speed this up in the background. For the final step, we're going to run the electrical rules check, or ERC. This simple tool allows you to verify that your schematic was properly made and connected before you move on to the board stage. For this, either use the ERC button, highlighted here in the ribbon, or run the command ERC in the command bar. We see that a window pops up with our output. This command can give us a variety of error messages, but the main ones we're going to look for are unconnected pins on parts and components without values. First, check off the centered box, so that when we click on the error or warning, we jump right to it. Let's solve this one issue we have. Looking here, we see that we have an unconnected pin on our LED. This is a quick fix, as we can just take the net tool and connect it to where it was supposed to go, which in this case is this transistor. Sometimes there'll be warnings that pop up which are not a major issue. These warnings can be approved by clicking the Approve button here. Once we have resolved all the problems or approved them, we can run the ERC one more time and see that we get no warnings or errors in the bottom left corner. That means we are done with this circuit. At this point, you should be proficient in moving from a physical circuit or schematic to one made in Eagle, including setting it up, adding all the parts, connecting the nets, and properly structuring it. Be sure to check out the RJ Style Guide and the SEC Wiki page in the description below to be able to read up on all the best practices for creating your circuits. Also, there's a cheat sheet link below that you can use as a reference for the future. Finally, follow the instructions in the description below to make what configurations you did the Eagle permanent. Now you can use this schematic to go to the next stage in this process, board design, to turn this schematic into a finished board that you can turn into a finished shield.